Hi, I'm Mr. V. Today's lessons from Illustrative Mathematics. This is Unit 1, the second half on rigid transformations, and this is Lesson 17, Working with Rigid Transformations. By the end of the period, you should be able to say, I can describe a transformation that takes given points to another set of given points, to another set of points. Now, to do a description means you have to be good with the language and good with words, which is what we're going to be practicing today, is writing these words. And first we have this idea of taking segment A to point B. Next is point B to point A, then from C to D, and from D to C. And you're supposed to describe a transformation that would achieve that. And we have three rigid transformations. They are translation, rotation, and reflection. In order to do a translation, you have to move from a point to a point. So you're going to go by a directed line segment. So I could say I'm going to move from point A to point B by directed line segment from A to B. So if you were to write the symbol, it would look like this from A to B. So I moved point A, that's what I'm moving, from point A to point B, or a long directed line segment from A to B. That's a vector. Another way to do this would be to reflect this across this line. So you could say, I'm going to reflect A across line CD. When you reflect it across line CD, this is the perpendicular bisector. It's what's doing the cutting. It cuts this into two equal parts at a perpendicular. So when you actually reflect it across it, you end up with B. That's what a definition of a reflection is. A third way of doing this would be to say, I'm going to take point A and I'm going to rotate it. When you rotate it 180 degrees around point M, notice these are all, this would be like the radius of a circle. So if you did a circle and you go 180 degrees, this would get you to itself. What doesn't work, and what some people struggled with, is to try to rotate C about point M. That would put it way over here somewhere, because this segment is shorter than this one. CD is not bisected. It is not cut into equal parts. This is what is doing the cutting. It's the bisector. AB is what is being bisected. So you can't say you're going to rotate around. You could say you're going to rotate it around the midpoint. I don't know where the midpoint is. Let's call it X. But if you did a rotation around the midpoint of 180 degrees, that would work. In the same way, you could say I'm going to reflect it across the perpendicular bisector. So if this is cut into two equal parts this way and this way, then you could say I'm going to reflect it across the perpendicular bisector to get from C to D, or to get from D to C. Probably the easiest way of doing this particular transformation to go from C to D would be to do a translation. I'm going to translate point C by directed line segment from C to D. Directed line segment C to D. Translate C by directed line segment from C to D. On this page, I give some instructions on how to do the chord sort. You can read this. There's two chord sorts. First one is when you have to put it into different categories. And what I say, so that this dilation, a dilation in one direction, a reflection, these are the main categories. And I explain it in the video, how it's to be done, and in the instructions on this page. In the second part of this, you come up with your own category, and then you describe for me what the basis of your category was. The two main categories that people came up with on their own was to say a dilation, where it's either getting smaller in one direction or smaller in both directions. And here we have, here we have rigid transformations, non-rigid transformations. Another category that was pretty common was to say I'm going to do triangles and quadrilaterals and things that are not triangles or quadrilaterals. So that's another way of categorizing them. Here I ask which cards are rigid transformations, and then I give the answer. What is a rigid transformation? It is a translation, a rotation, a reflection. What's the matter with this? But is in this move. Hold on just a second. Trying to get this thing to move. So it's a translation, rotation, or reflection. This is going to be translation. This is not. This gets smaller. It's a dilation. This is a translation. This is not. This gets smaller. This is a reflection. It is not a rotation. Notice if you try to rotate it, they will not land on top of each other. And this is a rotation. Rotation, rotation, translation, reflection. And now we come to the fun part and the interesting part of this lesson, which is these next 4 slides. And in each of these 4 slides, I'm not going to go through it here because I do it on the slides, but you're supposed to describe in words for me a transformation, either a rotation, reflection, or translation, or a series of combination of those that will map the pre-image onto the image. The pre-image does not have the prime symbols. This little apostrophe means G prime, H prime, I prime, J prime. This is, we're going from the pre-image to the image. And when you look at the response after you write yours, you can see here, I've written what it is supposed to do, and I've given you a video showing you how to do it on this if you wanted to try to do it. It's not necessary. What I'm really interested in is the words, and to try to get you to say it by the correct words. So you can compare your language with mine. And also on some of these, I give you a picture showing, well, we're going to translate it by C to C prime, and then we're going to rotate it by X, C prime, A prime. Here we have, this would be a rotation. First we translate it from W to W prime, and then we rotate it by A, W prime, V prime to get there. And here's the video of me showing you how to do that. And this one is a reflection. So Diego observed that it's easier and sometimes easiest to do this with one rotation, and all of these can be done with one transformation, a single transformation. Some of them are pretty easy to see, like the one, this translation, we translate from J to J prime by a directed line segment. Or maybe the one down here where you're doing a reflection. If you did the a segment between these two and found its midpoint and drew the perpendicular line to that midpoint, this would be the line of reflection. And so you could reflect it with one transformation. These others are rotations, but how do you find the center of rotation? I'm going to explain how, and if you follow it, that's fine, and if you don't, this is a little bit more advanced. So if we go from X to X prime and I draw a segment, and I draw the perpendicular bisector of that segment, it would look something like this. If I draw in a different color, I'll draw from Y to Y prime, and I look at the perpendicular bisector of it, it's going to go something like this. So it's going to be somewhere around here is where these two intersect. Somewhere around here where these two intersect. And if you did that for all of them, you'd find that they all intersect at the same point. That is the center of rotation. So how many degrees do we go? Well, if we make the angle, I'm going to go from W to the center to this W. If you do that, you're going to find that would be the angle of rotation. And here we're going to go, to get to this one, we're going to go clockwise, this direction. To show you that one more time with this last one. And like I said, this is a little bit more advanced. If we were to take a segment from B to B prime, we were to draw its perpendicular bisector, so go about halfway and then do a perpendicular, it's going to look something like this. If I do A to A prime, and I'll do this with the line tool as well, A to A prime, and I go halfway and I'm going to draw the perpendicular bisector, so it's going to go something like this. I end up with this point down here that is going to be the center of rotation. What is my angle of rotation? Well, when I go from A to the center to this point, this would tell me how far I have to rotate it. And if you did a circle around that point, here to here, here to here, the same degrees, you're going to end up with the same thing. So that's how do you find the center of rotation, and that's a little bit advanced, so not required. Here, Diego says I could do this. One way to do this is to construct your, well, I'll show you. If you look at these two slides and try them, there's a video of Miss Kirkpatrick explaining how to find this line of reflection. So I'm not going to mention it again here. You can watch her video. Same with this one here. These are both wonderful, wonderful 2-3 minutes movies that you really ought to watch because she puts a lot of information into these two little slideshows. Here's the summary. Notice we take this triangle EDF and we translate it by segment E to B to get to this E prime, D prime, F prime. And then we're going to rotate it around this point B by 90 degrees to get to this green triangle. And then we're going to reflect it. It's amazing that all triangles that are congruent can be mapped one onto the other with finite rigid transformations. You can do it with a translation, a rotation, and a reflection. Sometimes it takes just the translation. Sometimes it's a translation and just the rotation. But if you have all three of these, you can always get to one to the other. So for the exit ticket, here Priya has made up these two triangles. And she says it's impossible to get from one triangle to the other with one, either a translation or a transformation, I mean, a reflection or a rotation. And your object is to say why. And then you tell me how well you did for today's lesson. So good luck and success.